Okay, for the fourth recording here, we're going to go into Alzheimer's disease. I looked in your book, and your book only had a page or two about it. I should let you know that I used to do a lot of talks, pharmaceutical talks on Alzheimer's disease, and I know a lot about it, so I'm going to kind of go more with my knowledge and understanding of it, and your job is kind of be to take some notes and write down some information kind of in your own words on what I basically have to cover here. So Roman numeral number one is kind of the big picture with Alzheimer's disease. It is a disease that is very much on the increase. The elderly are being stricken by this, and the big picture is, if you know anybody with Alzheimer's disease, which is certainly on the increase, the question of what makes us human. And most people argue that what makes us human is our ability to have our personality and our memories. And when somebody gets stricken with Alzheimer's disease, it's a degenerative disease, meaning it's going to get worse and worse and worse over time. And it's going to rob us of our personalities and our memories. And that's really a bad thing. And eventually it's going to lead to mortality, which, once again, for family members, coping with our own mortality is a very difficult thing to do. You kind of have to work with your parents, if they're stricken by it, as if they're turning into little children again, and that's just a very hard role to do. I'm happy to say that the federal government is taking this very, very seriously. Senators and congressmen are of this age. We know the risk gets higher as you get older. So there are basically 29 research centers around the country. I think UVA has one of them. And they're trying to find out the causes, the treatments, diagnosing, and all sorts of things about Alzheimer's disease. So that's kind of the big picture about it. It's a very difficult disease to deal with. Let me go in with you now next into the pathophysiology of Alzheimer's disease. If you watch the little YouTube video, it might be helpful to you in terms of the pathology, but let me kind of show you the picture here and give you kind of the short and simple story of the equation. We all start out, we all have in our brain something called the amyloid precursor protein. Everybody has this. But for people who get Alzheimer's disease, it seems the amyloid precursor protein, which you can see in the picture, we all have, goes outside and inside the neuron, gets cut. And it gets cut by beta and gamma secretase. And when it gets cut by these secretases, for people that get Alzheimer's disease, the cutting of this leads to the formation of beta peptide. And beta peptide basically starts clustering in the main regions of memory in your brain, in the amygdala, in the hippocampus, in the limbic system, and will become aggregate. It'll aggregate, it'll cluster, and it'll start destroying all sorts of neurons there. So that's one part of the process that goes on. If you go down to the next section, like it says with the little chart there, chromosome 21, we all have amyloid precursor protein, but it gets cut by beta and gamma secretase, and that's what leads to this beta peptide forming in the amyloid plaques. Your brain recognizes that something is wrong here, so it has the inflammatory response. And one part of the brain that works with this is microglia. Microglia comes in and tries to destroy the amyloid, but unfortunately it ends up destroying not the amyloid, but actually a lot of healthy tissue, especially tissue containing acetylcholine. It also kind of changes glutamate receptors as well. And so basically what we have is microglia destroys the wrong cells, and we see changes to the acetylcholine and glutamate, and so no real help there. The other problem we have with the inflammatory response is chromosome 19 also goes into action, and chromosome 19 codes for three different types of apolipoproteins. They're called apolipoprotein E. And apolipoprotein E, let's see, did I spell it out anywhere here? You might have to go and look for that yourself, but apolipoprotein E, there are 3 different types of alleles for this. With apolipoprotein E2, when that is expressed, and this goes back into one of my old favorite shows, Star Trek The Next Generation, when apolipoprotein E2 is expressed, the neuron keeps its shape. The neuron keeps its shape. And so it kind of maintains the structural integrity of the neuron. Star Trek The Next Generation is we have a warp core breach, we're losing structural integrity. When apolipoprotein E2 is expressed, the neuron keeps its structural integrity. When apolipoprotein E4 is expressed, which seems to happen with Alzheimer's disease patients, that basically leads to all these negative things going on in the neuron. Microglia comes in, actually other things come in, and basically they'll lead to tau protein coming in if you look back at the picture, and the neuron will lose its structural integrity. If you look back at the picture, and you'll basically see these tangles form. So the microglia from the other side leads to the plaques forming, and this process with apolipoprotein E4 leads these tau proteins to basically crumble with the microtubules and lead to tangles. So we have the plaques and tangles. So we know this from all these research centers doing these studies. We know this is what occurs. Next, let's move into diagnosing Alzheimer's disease. It used to be very difficult to do this. You used to have to wait till autopsy to do it. But now we have some quick and simple ways of doing it. A clock drawing test is one way that we have of doing this. You ask people with Alzheimer's disease to draw a particular time, and many times when they can't draw a time, that's a sign of Alzheimer's disease. Another one that's actually been used, olfactory dysfunction. It turns out that in the hippocampus, it's very close where Alzheimer's strikes to the olfactory bulb, and people with Alzheimer's disease many times will start showing a lack of being able to identify smells. So that'll happen as well. And let's see, one of the ones that used to be used was the mini mental state exam. You may have heard of this one. This is one where you ask people to name certain things, and you could predict who was going to get Alzheimer's disease. There's a big study going on now at a lot of these centers where they're really trying to figure out how to diagnose things, and one of the best measures we use now is called the AD8 scale. The AD8 scale basically asks people, have you seen a change in X, Y, and Z? And this seems to have predictive validity, the ability to predict who is going to get and who is having problems with Alzheimer's disease. So the AD8 is the one that's currently used the most. And then finally, for diagnosing Alzheimer's disease, at one of the 27 or 29 research centers, a group of researchers out of Pittsburgh by the name of Klunk and Associates were able to basically figure out, they gave people this compound called Pittsburgh Compound B, since it was out of Pittsburgh, and they put these PET scans in, and they were able to see all the amyloid plaques forming in the brain. So it seems like now we have a way of neurobiologically figuring out who's got these amyloid plaques, and it differentiated between those with Alzheimer's disease and those with not. So at least now we finally have something quantitative with Alzheimer's disease. And if you go to abstract 3, the screening test, it looks like the AD8 one is the best one to use. It's better than the mini mental state one. It correlates very well with the formation of these amyloid plaques and the tangles going on. So next we go into current treatments. And actually, let me pause it here and just start current and future treatments. It's going to be a new recording.